Hi, my name is Dr. Cardona. I teach environmental science, earth science, oceanography, and meteorology at CCVC Essex. Some of you might already know me, but those of you that don't, if you find anything that's interesting in this lesson, you can always take environmental science with me or one of my colleagues to learn more. For the purposes of this trip, you're going to the Great Smoky Mountains, so I'm going to focus on issues that are relevant to that area. One of the biggest issues is that it is very close to what we call coal country. Coal country is Western Pennsylvania, West Virginia, Virginia, going down to the Carolinas, and at least North Carolina and parts of Tennessee. The Great Smoky Mountains is a national park that is between Tennessee and North Carolina. So you have an area that's close to one that has been used for coal mining and extraction. So I decided to talk about the impact of coal mining on this habitat because it affects the biodiversity of that environment. This picture is of Judy Bonds. She passed away a few years ago, but while she was active, she was a strong advocate for the stop of mountaintop removal. This is a terrible practice in which the top of the mountains are completely removed and habitat is totally destroyed to extract coal from underneath that top. So she made these t-shirts that say "Save the Endangered Hillbilly," playing on these stereotypes that are used to derogatively describe her community. Her father was a coal miner, her grandfather was a coal miner, and so on. So she was aware of the benefits of this industry and the money that could come in with limited education. But she also was aware of the negative health effects, like Black lung disease, that affect the people. And she was observant and seeing how the environment was destroyed, affecting that area, and also affecting the health of those people in that community with conditions such as baby blue syndrome that come from contaminated stream water. Why is this such a big issue? Well, when we remove the top of a mountain, you're completely destroying all the trees, all the grasses, all the habitat for all the plants, animals, fungi, and insects, and every kingdom you can imagine that live on the top of these hills or mountains. These are blown up to then extract the coal underneath, and this is what you're left with through this process. You can see that not only is everything destroyed from the top, that is complete habitat destruction, but all the debris has to go somewhere, so it goes to nearby bodies of water and contaminates that water. That contaminates the drinking water for the communities as well. Like I mentioned, blue baby syndrome is one of the many consequences that comes from this contamination. So you have habitat destruction, you have pollution, you have a lot of other consequences that come from this type of mining. There are other types of mining like strip mining and subground or subsurface mining as well. When we do subsurface mining, we end up with what we call acid mine drainage. When the mines are exposed to the elements, rain comes by, touches the mines, it combines with the impurities that are there left over from the coal removal, which includes bits of coal and impurities such as sulfur. When sulfur and water combine, you end up with an acidic substance called sulfuric acid. And you end up with these orangey, reddish, brownish water systems that are indicative of acidity that can only be remediated, if you will, or fixed if we add lime or some sort of base to counteract that acid. But these environments are very difficult to completely restore. This particular photo was taken by one of my friends, Colin, who studies the Pennsylvania mine and coal industry and takes many beautiful pictures that are sad, well-taken photos of sad things like this. The first picture was me. I took that one. Of course, when we look at what is causing the biggest issues in national parks, since national parks are there to preserve that environment, that habitat, we're looking at the importance of national parks as a place where that habitat is prevented from being destroyed. So there will not be mountaintop removal in the Great Smoky Mountains, but it's still feeling the effects of the nearby pollution. So keep in mind, water is the universal solvent. That is why you saw this picture. Water dissolved that sulfur and got it into itself as an ion that contaminated it. But in the atmosphere, it does the same thing. when we have emissions from factories, incinerators, coal power plants, cars, there's a lot of chemical contamination that comes out in the form of sulfur dioxide emissions through coal and nitric oxide emissions through industry and cars. So whenever you turn on a car, you're creating an energetic reaction that's going to combine nitrogen and oxygen in the atmosphere, creating nitric oxide, or what we call nitrogen oxides, which are NO or NO2. In this particular picture, you see NO. I'm not going to get into the chemistry of this too deeply, but notice that whatever comes in comes out. When sulfur dioxide and radicals of oxidants combine, we get SO3. Combined with H2O equals H2SO4. The molecules combine to create a new molecule known as sulfuric acid. Similarly, when nitric oxide combines with water, you end up with nitric acid. I should say that acid rain should be really called acid deposition or acid precipitation. Any type of acidity coming down in the form of rain, snow, hail, sleet, fog, name it. Could be acidic. But the point being that we have these emissions combining with atmospheric water vapor or steam, if you will, that then condenses in an acidic form and precipitates acid precipitation. And this affects the Great Smoky Mountains. So to understand what I'm referring to here, let's look at the pH scale. The pH scale goes from 0 to 14, 7 being neutral, but there is no such thing as pure water unless you're looking at deionized distilled water used in laboratories, where the ions that water dissolved have been taken away. Naturally, water from the atmosphere is acidic because we all breathe and we all exhale carbon dioxide along with all respiring organisms. So there's carbon dioxide coming out of our breath. There's carbon dioxide coming out of volcanoes and other natural processes like trees dying. I could go on forever, decomposition, etc. Release these substances into the atmosphere. They combine with water. You end up with nitric, sulfuric, or carbonic acids. Ocean water, on the other hand, is naturally basic. So it is above a 7. Anything above a 7 is alkaline or basic. And that is a substance that is basic because of the salts in it. Of course, there's something called ocean acidification that is a result of extra carbon dioxide in the atmosphere being absorbed by the ocean and making it more acidic, meaning that the ocean water should be at an 8.2, but is going down closer to a 7, making it dangerous for marine organisms. But on land, in national parks like the Great Smoky Mountains, we have naturally acidic rainwater. So natural water should be at about a 6, maybe a 5. So normal rainfall is about a 5 to 5.6. But the rainfall that we see in the Great Smokies, in this particular portion, which is Mount Mitchell, this is the Mount Mitchell State Park is nearby the Great Smokies. It's in North Carolina, near Asheville, North Carolina, about an hour away. And this area, you can see all these dead trees because the acid rain there is closer to a 4.5. And while it might not seem like a huge difference between a 4.5 and a 5.5, I should point out that this is a logarithmic scale, meaning that a 0 is 10 times more acidic than a 1, 1 is 10 times more acidic than a 2, moving closer to the alkaline substances, you get less and less acid. So a 0 is 100 times more acidic than a 2, or 1,000 times more acidic than a 3. While the numbers are only 1, 2, 3, 4, there's a big difference between each value. So if normal rain should be at a 5.6, and we're seeing rains down here at a 4.5, that is over 10 times more acidic than it should be. And what does acid rain or acid deposition do when it hits forests? It leaches out nutrients that are vital in the soil and either makes the trees have brown leaves and look kind of sick, or leaves empty needles like this, leaving the tree vulnerable to death and disease because they don't have the leaves to photosynthesize. So this is one of the biggest impacts we're seeing. nearby. And we're seeing this in the high altitude regions of the Great Smoky Mountains. You will go there for a hike to look at salamanders. So if you look at the trees and they look kind of sad and weak and sickly, maybe there's acidity involved in that cause of that health issue. Now, in general, acid has a reaction to calcite minerals. These are calcium carbonate, so calcium carbon and oxygen combined. This is actually why I mentioned that marine organisms are being affected by ocean acidification, because a lot of shellfish are made up of calcite shells. Plankton in the ocean also are made up of calcite. But on land, we're seeing the damage of acid rain on calcite substances, such as statues that are made often with limestone or marble. Limestone or marble are rocks that are composed of calcite. So we have like this statue on this left, this obelisk looked normal before when it was made. You can see very clear hieroglyphics. But look at the obelisk after it's been damaged by rain. You can see that it's deteriorated and you can't read it as clearly. It's not very intact, if you will. Why? Because when acid rain touches something like limestone or marble that are composed of calcite, it bubbles up and eats away at the substance, deteriorating it or kind of dissolving it, if you will. So what have we done to remedy this problem or address this problem? Legislation has worked for decades to fix the consequences of acid mine drainage and, more importantly, acid precipitation. In the case of acid precipitation, we wanted to prevent the excess sulfur emissions that cause sulfuric acid, the biggest source of acid rain. The biggest source being coal, because coal, when burned, the impurities of sulfur go into the atmosphere. So the cap and trade system was, or the cap and trade program was instilled during the Bush senior administration in the 90s to put regulation on how much sulfur can come out of coal power plants by putting scrubbers and different things on the smokestack that would prevent the gases from escaping the plant. So as you can see here, the importance of regulation is evident. So the cap and trade system, what it stands for, means that they would put a cap on the emissions in one particular area, and companies could trade permits to pollute between each other. So if one was a brand new factory, it had all the technology to prevent emissions, it could sell its permits to an outdated plant that didn't have the money to invest in making changes to prevent those emissions. So there was an incentive to those factories to improve their technology so they could sell permits rather than having to buy them. So we can compare here the soil acidity from 1990 to 2018, and anything that is orange is acidic at this point. You can see the majority of the acidity in the United States was on the East Coast, being that this was coal country right here in the Pennsylvania, West Virginia area. And you can see that that area is redder or oranger, if you will, than the rest. So that shows you the most acidic areas being the northeast of the United States, as winds move pollution from southwest to northeast in what we call the westerly wind, excuse me, not the trade winds. The trade winds are down here. Anyway, the westerlies push wind from the southwest to the northeast in the country, and that causes pollution from down here to move up there. So when these regulations were put in place and companies were allowed to trade permits, it incentivized it in a market-driven approach. So it was a regulation, which is a liberal perspective on environmental improvement or remediation, and it had the market-driven approach of a conservative president that was Bush. So we had a bipartisan agreement that created a moderate consensus between political parties and saw a change. We saw over time that those regulations and caps led to a decrease of sulfuric acid as a result of sulfur dioxide emissions. So you can see the sulfur dioxide emissions from 1990 were really high, at almost 16 million tons down to about 5 million tons in 2010. So that was a huge improvement in a matter of 28 years. We can see here a complete restoration of the Northwest, even the South, going towards a normalization of rainwater, so that the rainwater was now mostly in the fives, not contaminating the soil as much. So y'all are gonna get to go to the Great Smoky Mountains. I suppose I should have updated this to have a picture of last year's crew, but I decided to keep my old picture from when I was in college and went to the Great Smoky Mountains. Of course, I did this as a student, and now I'm taking y'all, which means that it's like a full circle experience for me. But I went to the North Carolina side on my course trip, and it was a plant systematics course where we identified plants. So you will not be doing that as much necessarily on this trip, but you're still going to get a hands-on real-world experience from the Tremont Institute instructors and yours truly, as well as our fellow faculty leaders. I hope that this was a helpful lesson to prepare you for this trip, and I look forward to seeing you in May. Thank you.